Okay, hello everyone. So, um, in last class we did up to MCQ 70. So, in today's class we will cover MCQs from 71 up to 80. So, मैं वेट कर लेता हूँ थोड़ा सा स्टूडेंट आ जाए तो फिर क्लास को स्टार्ट करते हैं. If you have any question in the last class, then please put that in the comment. I will give you answer. Okay, 71. That is, of the two bulbs in the house, one glow brighter than the other. Which two has the large resistance? Okay. So now we have two bulbs. Okay, and out of these two bulbs, one bulb glow brighter than the other. Okay. So the question is which of the two have a large resistance? Okay. So as we know that in our house the connection is in parallel. Okay, not in series. Okay. So in parallel, the voltage will remain constant. Okay. So we also have the relation between power, voltage, and resistance. That is like your power is equal to V squared divided by R. Okay. So voltage is constant, so it means that your power will have an inverse relation with resistance. So for large resistance, it means that the power will be less. Okay. If your resistance is high, then the power will have a small value. Okay. So now in dim light, okay, dim light will consume less power as compared to the bright bulb. Okay, the bright bulb will consume large power. Okay, so high resistance, low power. So we will have dim bulb. Okay, that will be the dim bulb will have the large resistance. Okay, so option A will be the correct answer. Okay, next MCQ, that is MCQ number 72. A DC supply voltage has an internal resistance of R ohm. Okay, a resistance load R is connected across the terminal of the supply. The power developed in R is maximum when the value of R is equal to. So we already studied about this theorem, the maximum power theorem. Okay, like what will happen in that theorem when your internal resistance become equal to the external resistance, then maximum power will transfer to the load. Okay, but there is one disadvantage, and that is the efficiency will be equal to, your efficiency will get decreased to 50%. Okay, so इसी वजह से हम इसको प्रैक्टिकली हम इसको यूज़ नहीं करते. इलेक्ट्रॉनिक सर्किट्स में मोस्टली हम इस थ्योरम को ज़्यादातर वहाँ पे यूज़ करते हैं. ओके, so in this case the correct option will be C. Okay, small r. Okay, next, that is 73. Okay, and today class we will cover this chapter. Okay, the question is, two identical heater coils are connected in parallel across the main. If one of the coil is break, the other coil develop lower temperature, develop same temperature as before, develop higher temperature, will also not be heated. Okay, so in this case we have two identical heater. Okay, connected in parallel. Okay, so let's say this is my heater 1 and this is my heater 2. Okay, both are connected in parallel across the main supply like this voltage. Okay, so if one of the coil break, okay, so let's suppose if this coil, like if this coil breaks, so what will happen, this heater will get disconnected. Okay, so now the question is the other coil, so this coil will develop lower temperature, develop same temperature as before, develop higher temperature. So you can like जो हमारे घरों में होते हैं वहाँ पे भी हमारे पास जो कनेक्शंस होते हैं, that's are in parallel connection. Okay, so if you have two rooms, okay, in one room we have heater 1 and in second room we have heater 2, and if you disconnect heater 1, then the heater 2 will give you the same temperature as before. Okay, so in this case your Option B will be the correct answer. Okay, like same, it will give you same heat as before, as we know that heat is directly proportional to power. Okay, H is equal to PT. In last class I discussed about this. Okay, so it means that it will give you same power. Okay, so that power is equal to V square divided by R, you can say, or that's equal to I square R. Okay. So when this heater disconnected, then what will happen? Your current will get decreased. Okay. So current in this heater is I1, current in this heater is I2, and the total current is I. Okay. So when it disconnected, then the current I1 will be equal to 0. So then your current, this net current will get decreased. Okay. Like this heater will consume the less current from this heater. Okay. So then I will be equal to I2. Okay. So this I will become equal to I2. Okay. Like the rating current of this resistor. This is the supply current. Okay, 74. That is the power rating of the motor driving at a current of 40 ampere at 400 volt is. Okay, so in this case, you need to find the power. Current is given to you and the voltage is also given to you. So that's too easy. Okay, we have this relation. We will use this relation, that should be equal to 40 multiplied by 4. So over here, what you will do, you will do mental multiplication. So you will get 16,000. Okay, so option A will be the correct answer. Okay, 75. The current in is 960 watt to 40 volt heater operated at 200 volt is. So this is the supply voltage and this is the rated voltage of the heater. Okay. Okay, so we need to find the current. So power is given to me, that is 960 watts. This is the rated voltage, that is 240 volt, but the supply voltage is 200. So as we know that the current, that will be equal to I is equal to. So first of all, you need to find the resistance. Okay? So you need to find the resistance, that's equal to P is equal to V square divided by R. So your power is 960 and your voltage is 240. So 240 square divided by R. So you have solved it. That will be equal to 240 multiplied by 240. 600 divided by 960. You will get 60. So your resistance will be equal to 60 ohm. So as we know that from ohm, the V is equal to IR. So your V is 200, okay, and resistance is given to that 60. So your current will be equal to this 0, cancel this 0, 20 divided by 60. So 10 divided by 3, option D will be the correct answer. Okay, 76. Okay, so one heater coil boils certain amount of water in 10 minutes and another heater coil in 15 minutes. In how much time the same water will be boiled if the two heaters are put in series? Okay, we have two heaters. Okay, one is this one and second one is this one. So this heater boil water in 10 minutes. Okay, and the second heater boil water in 15 minutes. So in how much time the same water will be boiled if the two heaters are put in series? Okay. Okay, so as we know that we have the formula that is H is equal to power multiplied by time. Okay, so in this case, first of all, you need to find the power. Okay, and in this case, both heater are in series. So your power of this will be equal to P1 and power consumed by this heater will be equal to P2. So as both are in series, so your total power will be equal to P P1 P2 divided by P1 plus P2. So as we know that H is equal to PT, so your P will be equal to H divided by T. But in this case, both heater will have the same heat. Okay. So this will be H divided by T. That will be equal to H divided by T1 multiplied by H divided by T2 divided by H divided by T1 plus H divided by T2. So your H divided by T, that will be equal to H square divided by T1 T2, and in the denominator you will get H, and you will take common at T1 plus T2 as a group up. In the denominator you will get T1 T2. So this will cancel by this, your 1H will cancel by this, your this H will cancel by this, so your 1 divided by T, that will be equal to 1 divided by T1 plus T2. So it means that your total time will be equal to, which will heat up the same amount of water, that's will be equal to the combination of both time. Okay, T1 plus T2. So it means that 15 plus 10, that is your 25. Option B will be the correct answer. Okay, MCQ 77, that is in the above problem, in how much time the same amount of water will be boiled if the two heaters are put in parallel. So you will apply the same technique. Okay, in parallel we have total power that is equal to P1 plus P2. Okay, so over here we have the formula that is equal to H divided by T. That's will be equal to H divided by T1 plus H divided by T2. So this will be cancelled by this. So your T will be equal to T1 T2 divided by T1 plus T2. इसको solve कर लो properly, so you will get this equation. Okay. So now you will use the same, that is 15 multiplied by 10 divided by 15 plus 10, that's equal to 25. So 6 minutes. Yes, option C will be the correct answer. Okay, next, that is 78. Two lamps of 100 watt and 200 watt rated for 220 volt are placed in series and at 440 volt applied across them. Then only 100 watt bulb will fuse, only 200 bulb will be fused. Both the lamps will fuse, no lamp will fuse. Okay, so in this case we have two lamps. Okay, and both lamps are put in series and 440 volt voltage is applied. This is 100, this is 200 and 220 volt. Okay, so first of all we need to find the resistance, that is equal to P equal to V square divided by R. So in this case that's equal to 220 square divided by R, which is 100. Like your R will be equal to this one. Okay, so your R will be equal to, R1 will be equal to 220 square इसको मल्टीप्लाई कर लेते हैं. So you will get 484. Oh, the second resistance R2 will be equal to 220 square divided by 200. So your R2 will be equal to 242. So this is your R2. Okay, so both are in series. Okay, so we need to find the current. So your current I will be equal to V divided by R, total R. So V is equal to 440 divided by total R 484 plus 242. So 242 plus 484, that's equal to 746. 726. 440 divided by 726, that's equal to 0.60. So your current will be equal to 0.6 ampere. Okay. Now you will need to find the voltage by using this current. So as we know that P is equal to IV. So your power is 100. Your current is 0.6. That's equal to V. So your 100 divided by 0.6, that's equal to 166. 166.6 volt. Okay, and for the second, that's equal to P is equal to IV. So P is equal to 200 and current is 0.6 is equal to V. So 200 divided by 0.6, that is equal to 333. So now this voltage 333 volt is greater than 220 volt, and over here this voltage 166.66 volt, that is less than 220 volt. So in this case your 200 watt lamp will fuse. Okay, because this lamp will consume a huge voltage. Okay, 220, like the voltage across this lamp is greater than 220 volt, that is 333 volt. Okay, so that's why this bulb will fuse. Okay, so in this case option B will be the correct answer. Okay, next is MCQ number 79. A coil of wire of resistance 50 ohm is embedded in a block of ice. What is the amount of ice melted in 1 second if a potential difference of 210 volt is applied across the coil? Okay, so in this case we have resistance is given to us. Okay, we have time is given to us, potential difference is given to us, that is 210 volt. So as we know that we have formula, that is H is equal to MS plus D. Okay, and we have another formula, that is H is equal to, this is NKW. Okay, H is equal to P multiplied by T. So over here we have voltage is given to us and resistance is given to us. So your this V will be equal to V square divided by A R. Okay, you use this formula. So your H will be equal to V is equal to 210 volt. Okay, so 210 volt square divided by R is 50, and time is 1 second. So from this you will get H, that is equal to 210 multiplied by 210 divided by 50, you will get 882. 882 joule. Okay. Okay, so now over here we will use this formula and you will use this one. Okay, 882 joule is equal to, in this case we have mass, that is you need to find that. Okay, and this is the specific heat. So the latent heat or ice is equal to 80. Okay, you will need to remember it. इनको ये देना चाहिए था but नहीं दिया, so you need to remember it, and you will take the temperature equal to 1 degree. But this is in calories, so you will use 1 calorie is equal to 4.18 joule. So from this you will get mass. So your mass will be 882 divided by 80 multiplied by 4.18. You will get 334.4. So now your mass will be equal to 882 divided by 334.4. You will get 2.63. This will be in gram. Okay. In gram. This option A will be the correct answer. Okay. Okay, next question, last question of this class is, in the circuit shown in figure 4.13, the battery has negligible internal resistance. The power supplied by the battery is, okay, if you have any confusion, then please put that in the comment section. Okay. So over here we have two resistance. One is this one, okay, and second one is this one, okay, and we have another resistance, that is the internal resistance, that is this one, okay, and we have the voltage source, that is this one. So these two resistance are equal to each other, okay, and we have this is 3 ohm, okay, this is 3 ohm, okay. Okay, so we need to find the power supplied by this battery. So what you will do, you need to minimize this circuit, like same resistance है, so in parallel it will become half. Okay, so ये क्या हो जाएगा, ये आपका 2 divided by 1 2 divided by 2 हो जाएगा, तो that's equal to 1 ohm, और यहाँ पे 3 ohm है, this is 3 ohm. So now both are in series, so you will get resistance that is equal to 4 ohm. Okay, this is 3 ohm. So now the question is, you need to find the power. So P is equal to V square divided by R. So as we know that V is equal to 3, so this is equal to 9. 3 square is equal to 9 divided by 4. So option B will be the correct answer. Okay, so this is the end of this class. Okay, if you have any confusion, then please put in the comment section. I am going to answer your question. Okay, see you in another class.